Hello friends, in this video I'd like to solve the following problem from the Finnish high school mathematics competition, final round 2001, problem number 5. We wish to find all positive integers n such that n squared plus 2 divides 2001 times n plus 2. So my hints for this problem, because you will see that this problem it looks easy, but it will be tedious along the way. We will be crunching large numbers. So first of all, check manually small cases. So from n equals 1, 2, 3, and so on, let's say up to 10, which of these numbers satisfy our divisibility. It will be useful, you will see in a moment. And then assume that our divisibility holds for some integer n, and consider the square of our second number, so 2001, n plus 2 quantity squared. So give this problem a try and see you in a minute. Okay, so I hope that you try to solve it. So it can be seen that n equals 6 and 9. After manual check, we will see that these two numbers satisfy our divisibility, and there is also one more number which satisfies it. It's 2001 itself, because 2001 plus 2 divides 2001 squared plus 2. It can be seen that these numbers satisfy our condition. In fact, I will show that they are the only ones. So let's assume that n squared plus 2 does divide 2001 n plus 2 for some positive integer n. Okay, and now let's consider 2001 squared plus 2001 n plus 2 squared. So it's 2001 squared times n squared plus 4 times 2001 n plus 4. And now I will do the following trick. I will introduce some new terms. So I will add 2001 squared times 2. And here I will write 4 times 2001 n plus 4 times 2. But now I have added this number, so I need to subtract it as well. And here I had plus 4, and here I have plus 8, so I need to subtract 4. And after doing that, I have 2001 squared, n squared plus 2, from these first two terms, and then I have, let's see, 4 times 2001 n plus 2, and finally I have minus 2 2001 squared plus 2. Okay, very well. But now look, by my assumption that this divisibility holds, by this assumption, this number is divisible by n squared plus 2. This number is also divisible by n squared plus 2. This number as well. So this last number must also be divisible by n squared plus 2. Okay. So what have I done? I removed from the right hand side of this divisibility relation, I have removed any occurrence of n. There is just a number on the right side. But here comes the hard part. This number is quite large. In fact, let's write it in white. 2 times 2001 squared plus 2 equals 2 times 4 million and 4003. It's quite a large number, and we need to factorize it. There is no other way around. Okay, or I don't see any other way around. Maybe there is a simpler solution, but I just don't know. Okay, so we need to factorize it, and to do it, there is no simple way to factorize a huge number. Well, if you are using some computer algebra system, it's quite easy, in fact. But let's assume that we are sitting our Olympiad, and we need to do it by hand. Well, by the first part, we know some numbers, in fact 6 and 9, which satisfy our condition. So if 6 equals 9, if n equals 6, sorry, then n squared plus 2 equals 38. And if n equals 9, then n squared plus 2 equals 83. So in fact, this number should be divisible by 38 and by 83. And in fact, it is. We will get 2 times 19 times 83 times, let me check my notes, times 2539. Okay, so we have some kind of factorization. The next tricky part, this number, it turns out to be a prime, but also it needs to be justified. So again, you should be, or I would check every possible prime up to the square root of this number, so about 50 or so. And I would check, I won't do it, I have better things to do. But I would check that none of the primes divide this number, so it must be a prime. Okay. And now another funny part, because we have how many? 1, 2, 3, 4 prime factors. So 4 prime factors. That means we have 16 divisors. 60 divisors. Because think about it combinatorically. By building our divisor, we can either take or not take any of these numbers. So our divisor can have a factor of 2 or may not have it. Two ways. It may have 19 in its product form, or it may not. Two possibilities. 2 times 2 times 2 times 2, 16. So that means that this number, n squared plus 2, which is positive, must be one of these 16 divisors. And here comes the next tedious part of our reasoning. We need to write all of them. And I will be cheating a little bit. It can be done by hand, yes. But I have written them down in advance. So here we have all of these 16 divisors. So n squared plus 2 must be one of these 16 numbers. after subtracting 2, it turns out that n squared must be one of these 16 numbers. And now another annoying part, it's to check which of these numbers are squares of positive integers. Turns out that they are only 3, namely 36 is a square, 81 is a square, and also there is one more square, namely the penultimate one. This is 2001 squared. And none other of these numbers is a square. 0 is also not a square of a positive integer, because in the problem we are dealing only with positive integers. So it means that n is either 6, 9, or 2001, and there are no other possibilities. So okay, so it's my solution. I'm pretty sure that there is a better solution to be found. If you know a better solution, please let me know in the comment section. But yes, a pretty sadistic problem in my opinion, because of the large numbers, because of problem of factorization of large integers. Hope that you learned something, hope that you endured through this video, and yeah, see you next time. Goodbye.